Alright, let's look at the homework 4.3, problem number 2. Alright, so look at this rational function, and then we want to find the interval increase and the interval decrease. Alright, so let's do that. Alright, so we need to look at the derivative. So f prime of x is equal to, alright, square the denominator, so x squared plus 1 squared, and derivative of the top is 2x times the bottom, x squared plus 1 minus top guy times derivative of the bottom, which is 2x. Right? So we can simplify this by denominator is going to stay the same. Then common factor would be there's 2x here and a 2x there. So pull that out. So you have a 2x. Right? Then you have leftover stuff is x squared minus x squared. So they actually cancel out. So you can cancel those out. Then you just have 1 left. So it's actually, that's it. So I'm going to actually clean up a bit. So this is 2x on top. Alright, so if you do a number line, alright, so x is going to be 0. Actually, maybe so if we set that equal to 0, you can see that x equals 0 is the critical number. Right? So what I have to do is check the sign. So anything less than 0, so I'll try x equals -1. Then you can see that the f prime is going to be, so this is negative, bottom is always positive, so you have a negative sign here. Alright, and anything bigger than 0, so x equals 1, and obviously that's going to give us positive. Right? So which means that it's decreasing before 0, increasing after 1. So I'll plug it in. Interval increase would be from 0 to infinity. So symbol infinity. Alright, and before that it's decreasing, so it's negative infinity to 0. Alright. And then find the local minimum or local maximum. Alright, so you can see that here using the first derivative test at this point, and its original function is decreasing and turn into increasing. So you can see that this is a local minimum. Alright, and f of 0, if you compute, plug in 0, so it's f of 0 is 0. So this is a local minimum. So local minimum is value is going to be f of 0 is 0. And local maximum value does not exist. It does not exist. Right? Find inflection points. Right? So let's do that. We need to find the second derivative. So f double prime of x is equal to, right? So 2 is just a constant multiple, so I put that in front. Then square the bottom, so you have x squared plus 1 quantity to the 4th power. Alright, so derivative of x is 1 times the bottom, which is x squared plus 1 squared, minus, top is going to be x. Then derivative of the denominator is 2. Quantity x squared plus 1, then multiply by derivative of the inside, so it's a 2x. Right? So let's clean this up a bit. So we have a common factor, which is x squared plus 1. There are 2 of them, so I'll take 1. So we get 2 is already in front, and x squared plus 1 is a common factor. And the rest is actually nothing else. So you have x squared plus 1 left over. Then you have 4 x squared. So it's going to be 1 minus 3x squared, right, all over, and x squared plus 1 to the 4th, right? We can actually cancel x squared plus 1 and turn that into cube. So we get this 2 times 1 minus 3x squared, and then you have x squared plus 1 cubed. Alright, so if you set that equal to 0, you can see that we set this guy equal to 0, so it's x equal to, alright, so we want x squared to be 1/3, so you have to take a plus or minus square root of 1/3. Alright, so we have that. So then we have to make sure that there's a concavity change there, so do a number line there. Alright, so it's going to be negative square root of 1/3 and positive square root of 1/3. Right? Then you look at the sign of f double prime. Right? So we can try anything, less than square root of a negative square root of 1/3. So it's going to be able to try negative 1. So if you plug in negative 1, so this is the second derivative, right? If you put negative 1 there, so 1 minus 3, so that's negative, so that's positive, so it's going to be negative here. Right, between these two guys, so I'm going to try x equals 0. You can see that the 1 minus 0 is positive, so it's going to be positive there. Everything else is positive. And you can try anything bigger than square root of 1/3, so I'll try 1. So 1 minus, so that's going to be negative. Right, so it looks like we have a concavity change here and a concavity change there. So both of those guys are inflection points. Right, so let's find the f of negative square root of 1/3. Right, then if you plug in, so it's 1/3, so 1/3 because it gets squared, so you have a 1/3 plus 1. So it's a 1/3 over 4/3, which means that the multiply top and bottom by 3, so it's a 1/4, right? And it's actually, this is an even function, plus or minus gives you actually exactly the same value, right? So let's plug it in. So we have inflection points would be, so negative square root of 1/3, comma 1/4, and the positive square root of 1/3, comma 1/4. Right. Then interval in which f is concave up and concave down. So let's see. So concave up between negative square root of 1/3 and positive square root of 1/3, and everywhere else it's concave down. So let's type that in. So concave up is between negative square root of 1/3 to positive square root of 1/3, and negative infinity, symbol infinity, to negative square root of 1/3, and union, so set, and positive square root of 1/3 to infinity. Alright, so that will do it. So let's check the answer. Submit for testing. Alright, it came back, and looks like we got all these guys correctly. Alright, that's it. I hope that this was clear.